Hello and welcome back to GCSE Science Simplified. Your pen lies to you. That black ink, it's almost never just one substance. It's a mixture, a combination of different dyes all blended together so perfectly that your eyes can't tell the difference. But today, we're going to expose it. This is your first GCSE Chemistry Core Practical, and it's all about separating mixtures to reveal what's really there. In this practical, you use two key techniques, simple distillation and paper chromatography. Both do the same job, separating mixtures, but in completely different ways. Simple distillation separates a mixture of liquids based on boiling point. You heat the mixture, the substance with the lowest boiling point evaporates first, it cools and condenses, and you collect it separately. This works because different substances turn into gas at different temperatures. So distillation is about separating by boiling point. Now let's move to the main event, paper chromatography. This technique separates substances based on how far they travel. Here's the key idea. A solvent moves through paper, carrying substances at different speeds, so they separate. Think of chromatography like a race. The paper is the track. This is the stationary phase. It doesn't move. The solvent is the runner, carrying everything forward. This is the mobile phase. It moves through the paper. Now, this is different. Different dyes stick to the paper differently. They dissolve in solvent differently. Because of this, they move at different rates. They separate out. Some run ahead, others, they get left behind. Let's look at the method. You start by drawing a baseline in pencil, placing small spots of ink on that line. Standing the paper in the solvent, you make sure that line doesn't go below the water. Now, here are the key details examiners care about. Why pencil? Why use a pencil line, not a pen? Because the ink would dissolve and interfere with your results. Why keep those spots above the solvent? If they're in the solvent, they'll just dissolve into it instead of travelling up the paper. As the solvent moves up, it carries the dyes with it. The furthest point the solvent reaches is called the solvent front. Once the paper dries, you get a chromatogram. This is where the marks are, and where many students lose marks. Here's what you need to be able to do. Spot pure versus impure substances. If there's one spot, it's a pure substance. Multiple spots means it's impure or a mixture. Then we can compare substances. If two spots line up at the same height, it's likely they're the same substance. It's how we can identify unknown substances. Now we have our RF values. This is a higher tier skill. You can calculate an RF value by dividing the distance travelled by the substance divided by the distance travelled by that solvent front. It gives you a number always less than 1, and it means that you can identify unknown substances and compare your results more accurately. Now, students make mistakes on here. Here there are the classic GCSE traps. Using a pen instead of pencil, letting the solvent cover the spots, measuring your lines from the wrong point, or forgetting to mark the solvent front. If you avoid these, you're already ahead of most students. Now, let's challenge your understanding. What would happen if you used permanent ink? It wouldn't dissolve, so it doesn't move. It doesn't work. Damn it, how do we fix this? We need to find a different solvent that will dissolve permanent ink. So why do different dyes move at different speeds? This is because of the differences in solubility and their attraction to paper. Some quite simply get slowed down and can't move through the paper as fast. Let's lock this in. Distillation separates by boiling point. Chromatography separates by movement through a solvent. The mobile phase moves, the stationary phase stays still. Chromatograms tell you whether a substance is pure or impure. It identifies the substances, and we can calculate RF values so that we can also finely tune and identify substances. Most importantly, what looks like one thing is often a mixture, waiting to be uncovered. Next time, we'll move on to the next core practical, building your understanding of how scientists test, measure, and analyse the world around them. Thanks for listening to GCSE Science Simplified.